Moving to question number 10. Okay. So what do we have here? A sociologist claims that children spend more time watching television in 1981 than children do today. Okay, I see their claim already right away. So, and that is alternative hypothesis that claim more, right? So alternative hypothesis, it's going to be mu1 is greater than the mu2. Why greater than that? Because they said they spend more time watching TV, right? And right away, alternative one is going to be mu1 less equal mu2. This is our claim. So conclusion, we will draw regarding this claim. So what else? Recently, a similar study was conducted. The result of these studies in hour per weekly are shown below, okay? Assume the population standard deviation is 0.8, so which means sigma 1 is 0.8, and sigma 2 is 0.7. At alpha equals 0.05, can you support the claim? Can you support the claim? Okay, let's go one by one. So we already stated the claim alternative, and accordingly complement is null. So the claim is that children spend more time watching television in 1981 than today. Okay, so next we need to find critical value. Critical value. So since our alpha is 0.05 and we have mu1 greater than mu2, which means it's a right tail, right? So, and our table shows the area to the left. So what we are going to do before we go to the table, we're going to do 1 minus 0.05, which is going to be 0.95, right? And 0.95, you are going to find using this 0.95, and obviously you are going to look in positive z-score table because you have 95% probability, right? And you will get positive critical value. And that critical value should be 1.64. It's only positive one because we have one tail, which is right tail. Okay, so what is the rejection region? To find the rejection region, we are going to use this z critical 1.64. So whatever z standardized is greater than z critical, which means z standardized is going to be greater than 1.64, and that is going to be rejection area. All right. Next, we need to find our standardized test statistics. Again, going back to our template that we have, and we are using again the same template. Why? Because variance are different. Why? How did I find out that variance are different? Standard deviation 0.8, standard deviation 0.7. Variance is a standard deviation squared. If I square, that still will be different, right? So I'm applying now to find out how much will be my z critical. So My sigma 1 is 0.8. Sigma 2 is 0.7. N1, how much is my N1? I'm going to count here. 1, 2, does it say here? Maybe I overlooked. No. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Since there are 2 lines, so it's going to be times 2, 30. So, and each of them is 30. 30 here, 30 there. Okay. And once I plug, I'm getting my sigma, standard error sigma x bar 1 minus x bar 2, and doing all calculation that you already know, and getting standardized test statistics. 0.62. Okay. 0.62. So N1 is 30. Let me add. N2 is also 30. Okay. So once I do the plug data in template, the answer I'm getting is 0.62. So from here, the decision I make, I am 0.62, it's falling in the fail to reject area. Excuse me. Right? 0.62. Therefore, we fail to reject null hypothesis, correct? Which means we reject alternative, which is our claim, right? So from here we're going to say there is not sufficient evidence to support alternative hypothesis. Okay, because blah 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 blah, amount of children who in 1981 much more, they spend much more time watching television than now. Question number 11. So number 11 is the difference between mean annual salaries of statisticians in Region 1 and Region 2 more than $8,000. To decide, you select a random sample of statisticians from each region. The result of each survey are shown to the right. Alpha is equal 0.1. What should you conclude? Okay, so first of all, we need to create our test, the hypothesis test, right? When it's the claim is more, region 1 is more than region 2, and that means it's going to be alternative hypothesis. Mu1, because it's given, before we would just put mu1 is greater mu2, but we didn't know by how much, right? Here it says it's more by $8,000. Therefore, we are going to write down different way. We are going to put mu1 minus mu2 is greater than $8,000. Okay, because already we know it's given number by how much. And accordingly, alternative 1 is going to be mu1 minus mu2 is less equal $8,000. Okay, so now we need to determine critical value. So our critical value, how much it's gonna be? because we have our alpha 0.1, and we have practically right tail test, correct? Then what we're gonna do, we're gonna take, because it's a right tail, but our table shows left tail, so here it is, so make picture clear, and I drew it last time also. It's a right tail, but our the table shows left tail. Therefore, what I'm going to do, put 1 minus 0.1, and it's going to be 0.9. So go find this in the table, find out how much will be my z critical. And for 0.9, which is going to be positive z-score, I'm going to positive z-score table, and I'm getting 1 point critical value 1.28. Hold on. 0.9. Let me double check one more time. Yes, 0.9, the closest I found 0.8997, so it's 1.28. All is good. So the critical for 0.9, okay, it's gonna be equal 1.28. So to determine the rejection region is going to be, this is our critical value, 1.28, and rejection region is going to be, standardized test statistics is going to be greater than critical value, which is 1.28. This is rejection, which means falling in the rejection area, right? Now, calculating standardized test statistics. Again, we are going to template. I'm not going to do in detail out loud because you already know how to do that. I'll just write down again so you will know which one we are dealing now. Divided by sigma x1 bar minus x2 bar, and we know sigma x1 bar minus x2 bar is square root sigma 1 squared over n1 plus sigma 2 squared over n2. Okay, and I got the z test statistics. I got 0.9. Okay, so from here, my the z test statistics is 0.9 because since it's less, z is less than z critical, then we fail to reject null hypothesis. Here it is, z critical. So fail to reject. Now 0.9, it's kind of close to mean, because mean is z at the point of mean, z is equal 0, and we have 0.9, a little bit above of mean. So we fail to reject null hypothesis. That means we reject our claim alternative hypothesis. If we reject our claim, that's mean at the 10% significance level, there is not sufficient evidence to support the claim. Okay, and what claim is, blah, 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 that the annual salaries of statisticians in region 1 is more than in region 2, by more than $8,000. Okay, moving to question number 12. Number 12. Use the t-distribution table to find the critical values for the indicated alternative hypothesis, level significance alpha, and sample sizes n1 and n2. Assume that the samples are independent, normal, and random. So we need to answer a bunch of questions here. No, actually A and B. So we need to find the critical values assuming that population variances are equal. There we go. Population variances are equal. Sigma 1 squared is equal sigma 2 squared. And in asking us to complete t-distribution, right? It's a table. To use t-distribution label. So here we need to find t-critical. Now, because we have a null alternative hypothesis, mu1 is not equal mu2, that means null is equal mu1. Null is equal mu1 is equal mu2, right? And this is claim. Oh no, the other one is claim. Okay, so t critical, and it's going to be plus minus y because we have to tell. So when the variance is equal, so our degree of freedom is equal n1 plus n2 minus 2. If you watch the lecture, you would understand where from it's coming. Okay, so from here, we are going to go to a t-score table, pick up our alpha 0.2 from two tails, right? And our t-distribution, it's going to, degree of freedom, it's going to be 18 plus 8 minus 2. So 26, 24. So it's going to be 24 here, degree of freedom, 24. And t critical, we are going to get 1.318. So since it's a two-tailed test, we are getting plus minus 1.318. B, now we need to find critical values assuming population variances are not equal. So sigma 1 squared is not equal sigma 2 squared. In this case, we are going to take the smallest sample size and subtract 1. So degree of freedom is going to be n2 in this case and minus 1. So again, since we have tail table, we take tail alpha that is equal 0.2, and significance level it's going to be 7. Degree of freedom is going to be 7. I'm sorry, I'm getting tired. Getting 7. So from here, we are getting the critical value. It's going to be 1.415. So T critical is going to be plus minus 1.415. Okay, moving to next. So next question is the following. What conditions are necessary in order to use t-test to test the difference between two population means? So remember in the lecture video I mentioned when variance or standard deviation of population is known, we don't care about sample size anymore. It's going to be z-test. Z-score test. When population standard deviation is unknown, then we use t-score test. T-standardized test. This one is z-test. Okay? So, and obviously samples have to be independent, randomly selected, normally distributed. Well, we are normally distributed, or each sample size is less than 30. If sigma is unknown, then we are going to look at sample size, that's for sure, to make sure it is less than 30. Okay. Question number 14. Explain how to perform two-sample test for the difference between two population means. Okay. So, number one, identify and state the claim, or rather saying, I guess, hypothesis test or claim, hypothesis claim. Number two, we need to identify level of significance. Alpha, level of significance. Degree of freedom, we need to identify, and then we are going to find critical value. I would rather say critical degree of freedom will come here, number 3, because it belongs to critical value, right? Figuring out, well, alpha also, then I will do this. In that case, it would be more proper to put all this all together, because alpha, the degree of freedom, gives us critical value. So let it be all together. Okay. So, and then we are going to make decision and find standardized z-score. Standardized test statistics. And draw conclusion. Conclusion and interpretation. Okay, question number 15. So we are dealing with number 15 now. Use t-distribution table to find critical values to the indicated alternative hypothesis, level, significance alpha, sample size n1 and 2. Assume the samples are independent, normal, random. Okay, question A. Find the critical value assuming variances are equal. Okay. Sigma 1 squared is equal sigma 2 squared. To find critical value, what do? We need to know degree of freedom to go to address to t-table. So degree of freedom, when we have equal variances, it's going to be n1 plus n2 minus 2. That's going to be 10 plus 2 and minus 2. So it's going to be 10. And based on alpha also, given alpha 0.1, since we have left tail, so we are going to use here, it's a left tail, so we are going to use t-table, t-score table with alpha 0.1, and it's a left tail, find one tail, and the degree of freedom 10. So you should get, since it's a left tail, right? It's less than, so it's a left tail. You should get with critical value, t critical, going to be with negative sign, 1.372. And B, we need to find critical value if variances are not equal. In that case, we are going between two degree of freedoms. We are choosing the one that is less. So sample size n2 is less, then degree of freedom is going to be n2 minus 1, which is going to be equal 1. So again, left tail, alpha 0.1, one tail, and degree of freedom is going to be 1. I'm sorry, why am I saying 0? I thought I haven't subtracted yet from 1. Okay, so we already subtracted 1 and result is 1. So degree of freedom is 1. And critical value is going to be 3.078, and obviously it's going to be with negative sign because we have left tail, and that's going to be negative. Okay, moving to question number 16. 16. What do we have here? A pet association claims that the mean annual cost of food for dogs and cats are the same. Okay, so mu1 is equal mu2 are the same, keyword. And that's going to be our claim is null hypothesis. Hence, alternative mu1 is not equal mu2. All right. The result for samples for the two types of pets shown below, alpha is equal 0.01. So can you reject the pet association claim? Assume the population variances are not equal. When we have are not equal, what do? We take the smaller sample size and get degree of freedom from smaller sample size. Randomly independent, population normally distributed. Okay, so first question we need to find, stay at how looks like the claim. We already have it. So what is correct claim would sound like? The correct claim would sound that the mean annual cost of food for dog and cats are equal, which we have it. Okay. Next, what are null hypothesis and alternative hypothesis? We already have it here also. We have written down. So which hypothesis is claimed? We have it also, null hypothesis. We answered already a lot of questions here. And lastly, find critical value. Okay, to find critical value, since sigma 1 squared is not equal sigma 2 squared, then we are going to use degree of freedom that is equal n minus 1. So it's going to be n is equal 9 and degree of freedom is going to be equal 8. So since we have two-tail test, right, we are going to use alpha two-tail in the t table and degree of freedom 8. So, and we will get the critical value. T critical will be equal plus minus 3.355. Guys, turned out I thought I had turned out on recording, and I was recording and wrote down everything recording, and I didn't record anything. So therefore, I'm not going to clean and just rewrite over again. I just cover it over. So what I did. So based on degree of freedom equal 8 and alpha equal 0.01, we will find T critical plus minus 3.355 because we have two-tail test, right? Here it is, mu1 equal mu2. From here, we are going to find, we have T critical, we need to find standardized test statistics. Standardized test statistics, you are using exactly same formulas as standardized test statistics for Z score, with the only difference, instead of sigma we use S. So instead of standard deviation of population, we are using standard deviation for sample. And you use exactly same formula, so you can use the Excel template. So from here you are going to get, from template plugging in, you get standardized test statistics 2.474. What does that mean? If we look here, 2.474, it's falling in fail to reject area, which means we fail to reject null hypothesis. And once we fail to reject null hypothesis, we say there is not sufficient evidence to reject null hypothesis. Okay? Moving to question number 17. what do we have? A magazine claims that mean amount spent by customer at burger stop is greater than, I see here right tail already, greater than mean amount spent by customer at Fry World. That means my mu1 is greater than mu2. And that is going to be my claim. The result in, let me finish this, might as well, mu1 is equal mu2. So the result of samples of customer transaction for the two fast food restaurants are shown below, okay? Alpha is equal 0.05. So can you support the magazine claim? Assume the population variances are equal. All right, we got population variances are equal. Crucially important, it's going to be completely different calculation. Assume the samples are random and independent, populations are normally distributed. Okay, identify the claim, we already did that part. So moving to finding critical values. Okay, since to find critical values, we have one tail test, it's a right tail, so practically we are going to use alpha and degree of freedom. And degree of freedom is going to be, since the variances for samples are equal, we are going to take smaller the sample size, which is n2, and degree of freedom is going to be n2 minus 1, which is going to be 10. So if you go to table and look at alpha with degree of freedom, your critical value, T critical, is going to be 1.717. And our rejection region is going to be, let me see, we have right tail, right? It's greater than, and this is 1.717. So if our standardized test is greater than 1.717, then it will be rejection area. Okay. Next, we need to find standardized test statistics. Okay, here when for variances are equal, here you are going to go to template in Excel, and you are going to use the other sheet, number 2, where that crazy formula in there. Let me write down that formula so you will know precisely which one you are going to use. Okay, so of course standardized test statistics is going to be equal x1 bar minus x2 bar minus mu1 minus mu2 divided as x1 bar minus x2 bar. Okay, and from here what we're gonna find out, how much is gonna be our S for difference of mean. Remember that formula is going to be, and I didn't want you to go through all this trouble, therefore I put in there. So it's gonna be sigma head times 1 over n1 plus 1 over n2, where sigma head is equal n1 minus 1 times s1 squared plus n2 minus 1 s2 squared divided by n1 plus n2 minus 2. So all this in your template, all you have to do, just plug the information, the input data, which is whatever is asking for. Let me see, S1, S2, N1, N2, and you will get the answer at the very bottom of this Excel. Okay, so and result you should get, if you plug in the data, for standardized test statistics, it should be 1.921. So let's see, we have right tail, right? Yes, we have right tail. Well, I can put, let me put this null hypothesis less. Okay, it's not a mistake, but either way. All right, so right tail, okay, and critical value 1.717. So we have 1.9. Oh God, so we are going to reject null hypothesis. Okay, reject null hypothesis. That means we have, do we have to interpret? Yes. That means at significance level 5%, there is enough or sufficient evidence to reject. Oh no, hold on. Our claim is alternative. Okay. If we reject, then we fail to reject. Alternative. Okay, alternative hypothesis. And that's mean at 5%, I was going to say 5% interest rate. So what do we have? At 5% significance level, there is sufficient evidence to support the claim of the magazine that the mean amount spent by customers at Burger be greater than mean amount spent by customers at Fry World. So we put enough or sufficient evidence to support alternative hypothesis. Okay, so we have only last question left, question number 18. So let's solve the last question, number 18. An engineer wants to know if producing metal bars using a new experimental treatment rather than the conventional treatment makes a difference in the tensile strength of the bars, the ability to resist tearing when pulled lengthwise. At alpha level 0.1, answer the following questions. Assume the population variances are equal, okay? Important. Samples round, the random. Use technology to solve problem. All right, we are going to use technology. So the claim is that the new treatment rather than the producing metal bars using the new experimental treatment rather than the conventional treatment makes difference. That is your claim, that new treatment makes difference, okay, in the than previous treatment. So what is going to be our make difference? Difference meaning mu1 is not equal mu2, right? So and that's going to be our alternative, which is going to be our claim. And this is our claim. And accordingly, now it's going to be mu1 is equal mu2. Okay, so we need to find critical value. Okay, since we have to tell, again, alpha is equal 0.1. Yes, alpha equals 0.1 for to tell. And for degree of freedom, since we have variances are equal, we are going to take smaller one, sample size, which is experimental, 1, 2, 3, 4, 5, 6, 7. This is 7. This one is more than 7, so I don't even count it. Yeah, oh, we need to calculate standardized test statistics. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This one is 10. Sample size is 10, 7 and 10. So degree of freedom is going to be equal 7 minus 1 equals 6. So we use here 6 as a degree of freedom, alpha 0.1. And since it's to tell, you are getting T critical equal plus minus 1.753. And now we need to, it's asking what is going to be the rejection area. For rejection area, it's going to be greater than 1.753 and less than negative 1.753. T critical negative. Okay? All right, so what do we have then? Standardized statistics, right? So we can compare. So for standardized statistics, we are going to go again to the same page, which is going to be sheet 2, yeah, and it's going to be for the same formula. I wrote down here. Where is it? Here. Let me make a copy and move there, or just move down since I used there already. Here it is. And once you plug and get the result for test statistics from template, here you are going to get 0.662. Okay, so 0.662 is falling in healthy area. There we go. So we failed to reject null hypothesis, which means we reject alternative. And our claim is alternative. We are saying that 10% significance level, there is not enough evidence to support. That's all. Not enough evidence to support the claim. Hallelujah, I am done. The whole day I spent sitting and recording lecture and now assignment. But at least I got it done. I kept my promise. Okay,